Hi, this video is about pH, and we're going to be using the hydrogen ion concentration and hydroxide ion concentration to determine pH. All right, so how do we define pH? Well, it's defined as the negative logarithm of a hydrogen ion concentration. And when we say concentration, we mean molarity, moles per liter. So pH is the negative log of your proton concentration. And so you can see that equation here on this slide. Whenever you see this P, it means negative log. So it's a negative log of the proton concentration or hydrogen ion. And you know, if we go back to the very beginning of the year, a hydrogen atom has one proton, and if it's neutral or it has no charge, it has one electron. But now, if it has a positive charge, it got that positive charge by losing the electron. And so when we write an H+, it's nothing more than a proton. So you may hear me calling H+ ions protons, and that's because that's what it is. All right, so pH doesn't have any units, and it's a number between 0 and 14. Acidic solutions have a pH that are less than 7. Basic solutions have a pH greater than 7, and neutral solutions have a pH that is exactly equal to 7. All right, now, as your pH goes up, it's becoming more basic, so it means that there are less protons in solution. All right, well, there's another scale that's called pOH, and remember P, this P here means negative log. This is the negative log of the hydroxide ion concentration. Now, bases are known as producing hydroxide ions in solution. Remember we said if you were looking for an acid, be on the lookout for that H out front. So we said, hey, that's an acid, hydrochloric acid, and we had nitric acid because of that H out front. Well, now for bases, we're on the lookout for hydroxide ion concentrations. So things like sodium hydroxide or calcium hydroxide, things with a hydroxide ion concentration. So if you get your hydroxide ion concentration, and we know how to do that from our last video of getting the molarity of ions in solution, you take the negative log of it, you get your pOH. Now, what's the relationship between pH and pOH? I bet in biology class you never talked about pOH, you only talked about pH. When you take environmental science, you're going to talk about pH a lot, not pOH. Well, pH plus the pOH equals 14. So if you have a measurable amount of hydroxide ion concentrations, you can calculate a pOH. But to make sense to the scientific community, they're probably going to want to talk about things in terms of a pH. And to get a pH, it's going to be 14 minus that pOH. All right, so here let's practice some problems. All right, so a typical bottle of table wine has a proton concentration, and remember this is our proton, of 3.2 times 10 to the negative 4th molar, and they would like to know the pH. Well, the pH is equal to the negative log of 3.2 times 10 to the negative 4th. Now, if you didn't have a calculator and you had to estimate the pH, here, this is, log of base 10. Your pH is going to be between 3 and 4. But we have a calculator, and what we're going to do is you are going to hit negative log and then punch in your number. Remember, this times 10 you're going to use, don't hit times 10, we're going to use the engineering exponent. And when you do this on your calculator, you're going to come up with a pH equal to about 3.9. So wine is acidic because its pH is less than 7. So I want you to have a calculator, and I want you to be sure that you can plug this into your calculator the right way and get the right answer. Okay, now we can go backwards. Some acid rain has fallen, and its pH is 4.82. So that's fairly acidic. And they would like to know the proton concentration in that rainwater. Well, now we're going backwards. We have the pH and we want the proton concentration. Well, the proton concentration is equal to 10 to the negative 4.82. And on your calculator, the second function of your log is a 10 to the x button. So I'm going to hit second, because it's a second function on my calculator, log, and that's going to make it a 10 to the x button. And then I'll type in negative 4.82. And when I do that, the answer I get is 1.5 times 10 to the negative fifth, and that would be molar. All right, now hydroxide. Ooh, now we're talking something OH minus. In blood is 2.5 times 10 to the negative seventh. What's the pH of blood? Well, we can only calculate a pOH because they gave us the hydroxide ion concentration. The pOH is the negative log of 2.5 times 10 to the negative seventh. All right, so our pOH is going to be somewhere between 6 and 7. And so when we push negative log and we enter this value, we're going to get 6.60 as our pOH. Again, the scientific community almost always talks in terms of pH. The question has asked us about pH. So the medical community would want to know what's the pH of blood, not the pOH. So the pH is going to be 14 minus that pOH that you calculated. And so the pOH of blood, the pH of blood is 7.4. And blood is slightly basic. Maybe you learned that in biology last year. So the pH is around 7.4, slightly basic. All right, now this is where things can get a little bit tricky, but I don't think we're going to trick you. They would like the pH of a solution of 0.02 molar barium hydroxide. And so the hydroxide ion concentration is, it's not 0.02, it's 0.04. And we did some of these problems in class the other day. It's 0.04 because you've got those two hydroxide ions floating around for every barium ion that's floating around. So its concentration is 0.04. The hydroxide ion concentration is 0.04. Well, now we can definitely do this problem. So the pOH is equal to the negative log of 0.04 molar. And that is going to be somewhere between, I think, 1 and 2. And when we calculate that, the pOH winds up being 1.40. The question asked for the pH, and it is 12.60. All right, we would know, hopefully looking at this solution, we know, ooh, that's a base. It has hydroxide in it. That's a base. It should have a pH above 7, and we calculated a pH that is above 7. Again, we had to calculate the pOH first because hydroxide ion is what we had, but we can get a pH from a pOH very easily. All right, sig figs. Okay, well, the number of decimal places in your log is going to be equal to the number of sig figs in your original number. And so I hope I've been doing a pretty good job in this video with that. On the AP Chemistry exam, they allow you plus or minus 1 sig fig when it comes to logarithms. But let's try and use the right number. All right, so finally, how do you measure a pH? Well, we have pH meters in the lab, and we're going to use them. And they will give us the pH of solutions. You just stick a probe in, and it will read the pH for you. You can also use indicators. They're less precise than a pH meter, and they change color at some pH range, and they're pretty cool to use. And this is just a chart of some common indicators that are used. Here we've got our most common one is called phenolphthalein. And at pHs, here we go, below 8, phenolphthalein has no color at all. But once your pH gets above 8, it turns pink. So phenolphthalein is an indicator that I want you to know turns pink in a base, or pH is, you know, above, it really seems to turn right around 8 or so. But look at all these other choices you have at different pH ranges. And methyl violet's a really cool one. At really, really low pHs, it's yellow. At around 1, it turns to teal. And then anything from 1.5 and above, it's this pretty purple color. Methyl red goes from red to kind of a yellowish color. So they're really cool to use, but the one that we're going to use the most is going to be phenolphthalein. All right. So also, I would like you to be able to answer a question like this. If phenolphthalein turns pink in a solution, is it acidic or basic? And based on that very last slide, you would say, well, it's basic because phenolphthalein is pink in a basic solution. You don't need to know those other indicators, but phenolphthalein is so common. I just want to make sure that you know that one. All right. Well, I hope that this, you know, I hope you understand pH and pOH and how you calculate it. Again, you're going to be seeing pH in environmental science. You've seen it in biology. This is how you calculate pH and what it means. Have a good day.